Hello everyone, and welcome to this tutorial on reflection, which is one of our 4 transformations. Remember, a transformation is a process which can change the position and or size of a shape. In maths we have 4 transformations. We have rotation, enlargement. Remember not to be fooled with the word large. It can sometimes make the shape smaller. We also have reflection and we have translation. Today's lesson we'll be looking at reflection. Reflection is everywhere. You've probably seen dozens of reflection today already in mirrors, water, puddles, mobile phones, etc. So what is the definition of reflection? Well, a reflection is a transformation which gives a mirror image of an object using a line or plane of symmetry. A reflection does not change the size, but does change the orientation. It's important to note that when we reflect, the distance from the object to the mirror line is the same distance as the reflected image is to the mirror line. They are always 90 degrees or perpendicular from the mirror line. This is very important even when we were to slightly rotate our shape and put our mirror line on a slight gradient. Each vertex still remains to be perpendicular to our mirror line, and the distance from the object to the mirror line is always the same. So now we know our definition, and we know the most important part associated with reflecting an object to give an image, where the reflected image is always the same distance and perpendicular to the mirror line. I'll be showing you 2 ways to reflect, one with tracing paper and one method without tracing paper. Remember, in an exam, students must request tracing paper if you want to use it in an exam. So let's have a look at a past exam question. Here the question wants us to reflect the shaded shape in the mirror line. The first method I'm going to show you is where we count, using our knowledge that the reflected image is always the same distance and perpendicular to the mirror line. You can see this vertex, which is 1 square away, perpendicular from our mirror line. So therefore our reflected vertex is going to be 1 square away and perpendicular from our mirror line. Here we are 1 square away and perpendicular, so our next vertex will be 1 square away. Our next vertex is 1, 2, 3 squares away. So therefore the distance must also be 1, 2, 3 squares away. Our next point is 1, 2, 3 squares away perpendicular to our mirror line, so therefore we're 1, 2, 3 squares away remaining perpendicular to our mirror line. We repeat this process with each vertex, ensuring that we are constantly perpendicular and counting carefully from the mirror line to our object. As you can see, we've drawn our completed reflected image, which we simply highlight. Now let's do a question with tracing paper. Let's first start by placing the tracing paper over the diagram. Then tracing our mirror line, then tracing our object exactly. It's very important that we trace our mirror line and our object exactly. From here, let's lift up our tracing paper, then turn our tracing paper over and lay our tracing paper back down. As you can see, our reflected image is on the other side. What's important to do now is to line up our mirror line with the original mirror line. You can see that we have our object and our reflected image. We then press down really hard on our tracing paper. You can even indicate each vertex if you want. Then from here, you simply lift up to reveal your reflected image using the mirror line. Now let's look at another question. The diagram shows triangle ABC drawn on a centimeter grid. We're asked to reflect the triangle ABC in the x-axis. See if you can give it a go and press pause if you need. Using the method that the reflected image is the same distance and perpendicular to the mirror line, let's start by identifying our mirror line. Well, from the question we know it's the x-axis. So let's start with point C. Perpendicular and counting from our x-axis, we know this is 1 square away, so our new vertex will be 1 square away. B, we know is 1 square away perpendicular from the x-axis, so we know it's 1 square away. Finally, A, perpendicular from the x-axis, we can count 1, 2, 3, 4 squares away, so therefore it's 1, 2, 3, 4 squares away. From here, I've reflected triangle ABC in our x-axis. If you're given a diagram with labelled vertices, it's good practice to show the transformed vertices as A', C', and B'. It's not required, but it's good practice. Moving on to another question, it asks us to reflect triangle A in the y-axis. See if you can give it a go and press pause if you need. Using the reflected image as always the same distance and perpendicular to the mirror line, let's first identify our mirror line, which is the y-axis. From here, let's identify each vertex at a time. Counting carefully, you can see that we are 2 squares away perpendicular from our mirror line, so therefore our new vertex will also be 2 squares away. From this vertex, we are 2 squares away from our mirror line, so therefore we're going to be 2 squares away. Lastly, you can see perpendicular to our mirror line, we are 4 squares away. So therefore, we must be 4 squares away from our mirror line to give our new vertex. From here, we simply identify our reflected image. Here the question shows us triangle P drawn on a grid of squares. On the grid, we're asked to reflect triangle P in the line with equation x equals -5. So let's first identify where the equation of the line x equals -5 is on our grid. Well, it means wherever you go, x will always be -5. For example, at this point here, -5, 0. At this point here, -5, 1. Wherever you go, we will always have x as -5 as our coordinate. So therefore we end up with our equation of our line. Now, using our knowledge that the reflected image is always the same distance and perpendicular to the mirror line, let's count carefully. Perpendicular from our mirror line, you can see B is 2 squares away. So counting, we know gives B', which is 2 squares away. We know C is 1, 2, 3, 4 squares away perpendicular from the mirror line. So therefore C' is 4 squares away. A is 1, 2, 3, 4 squares away perpendicular from our mirror line, so therefore A' is 4 squares away perpendicular from our mirror line. We can then identify our reflected triangle P in the line of equation x equals -5. Now let's look at another question. Here the question wants us to draw the reflection of the shape in the line y equals -1. See if you can give it a go and press pause if you need. Using our knowledge that the reflected image is always the same distance and perpendicular to our mirror line, let's identify our mirror line first. Well, we know y equals -1 is our mirror line. So that means wherever you go on the line, y is always -1. For example, the coordinate 0, -1 here has the y coordinate -1. This is the coordinate 1, -1. This is the coordinate 2, -1, so on and so forth. So you'll notice wherever we go, y is always -1. Now we've identified our mirror line, let's identify each reflected vertex. Well, this vertex is 2 squares away perpendicular from our mirror line, so therefore our new vertex will be 2 squares away. Here we have 2 squares away perpendicular from our mirror line, so it's 2 squares away. We repeat the same process for each other vertex. Here you can see we are 4 squares away perpendicular from our mirror line, so we're 4 squares away. Here you can see this vertex is 4 squares away perpendicular from our mirror line, so it's 4 squares away. This vertex is 3 squares away perpendicular from our mirror line, so it's 3 squares away. And finally, you'll see this vertex is also 3 squares away perpendicular from our mirror line, so we have our completed reflected image. So let's look at a slightly harder question. Here we have a grid and we're asked to reflect shape A in the line y equals x. In this question, I'm going to show you 3 methods to tackle this question. Remember, in mathematics, there's always more than one way to find a solution, so it's important to find the method that best suits you. So let's start with the fact that the reflected image is always the same distance and perpendicular to our mirror line. I'm going to start with this vertex. You'll notice we're using a diagonal because we need to be perpendicular to the mirror line. So we're on a half of a diagonal square from our mirror line. So therefore our new vertex will also be half a diagonal square away. Our next vertex is 1.5 diagonal squares away, which makes our perpendicular to our mirror line. So therefore we must go 1.5 squares away from our mirror line, which is always perpendicular. Our next vertex is 2 diagonals away from our mirror line, ensuring that we are perpendicular. So therefore we're 2 diagonals away, perpendicular to our mirror line. Finally, this vertex is 1.5 diagonal squares away from our mirror line, ensuring that we're always perpendicular. So we must be 1.5 squares away from our mirror line. As you can see, we've reflected our shape A in the line y equals x. Another way is to look at the equation y equals x and to understand what it means. Well, it means if we were to identify our coordinate, for example 1, 2, this means that the x becomes the y and the y becomes the x. So our new coordinate would be 1 would now be our y coordinate and 2 would be our x coordinate, which you can see verified here. Our next coordinate we have is the coordinate 1, 4. So mapping this across, you can see our x coordinate now becomes our y and our y coordinate now becomes our x, which you can see with the coordinate 4, 1 here. Looking at our next coordinate 0, 3, you can see our x coordinate now becomes our y coordinate and our y coordinate becomes our x coordinate, which is verified here. And lastly, our coordinate 0, 4. You can see here that our x coordinate becomes our y coordinate and our y coordinate becomes our x coordinate, which is verified here. The next method I'm going to show you is using tracing paper. Just like before, let's lay down our tracing paper. From here, let's draw the exact length of our equation of our line. Then let's copy our object exactly. Then lifting up our tracing paper, we flip our tracing paper over and lay it down. You can now see the reflected image on the other side of our mirror line. Now it's important to line up carefully the mirror line with the mirror line from the exam question. Then you press down really hard on our reflected image. From here, once you lift the paper up, you'll be able to see your reflected image in the mirror line y equals x. Now let's look at a slightly harder question. The question shows us a grid and we're asked to reflect shape P in the line y equals minus x. See if you can give it a go and press pause if you need. I'm only going to show you 2 ways to tackle this question, but you can use tracing paper if you prefer. The first one is using our knowledge that the reflected image is always the same distance and perpendicular to our mirror line. So it's important to identify what the mirror line y equals minus x means. Well, it means whatever the y coordinate is, the x coordinate is the negative of that, and vice versa. So if I have x equals minus 1, therefore the y coordinate has to be 1. If I have the x coordinate of minus 2, that means the y coordinate must be 2. So from here you can see we have our equation of our line. Then we can count carefully and identify our perpendicular. Well, this vertex, as you can see, is one diagonal perpendicular to our mirror line, so therefore our new vertex will be one diagonal perpendicular to our mirror line. My next coordinate is 1, 2, 3 diagonals away from our mirror line, so therefore it's 1, 2, 3 diagonals away. Finally, our last coordinate. Keeping our line perpendicular to our mirror line, you can see we are 1, 2, 3, 4 diagonals from our mirror line, so it's 1, 2, 3, 4 diagonals from our mirror line. Here we can draw our final reflected shape. Another way to tackle this question is to understand the equation of our mirror line by pulling out each vertex. So let's start with the vertex minus 1, 3. Well, if the y becomes the x and then we invert the signs, this means minus 1, 3 becomes minus 3 plus 1. Looking at our next vertex, you can see we have the coordinate 3, 3. So this means my y coordinate becomes minus 3 and my x coordinate becomes minus 3. Lastly, you can see we have the coordinate 3, 5. So this means our y coordinate becomes minus 3 and my x coordinate becomes minus 5. You can see all coordinates verified on our reflected image. Now let's look at describing. Here we're shown two shapes on a grid, and we're asked to describe fully the single transformation that match shape P onto shape Q. Remember, when describing reflection, it's important to state the equation of the mirror line. It's 2 marks, so therefore we must identify 2 important things to get the full marks. See if you can give it a go and press pause if you need. The question states single transformation, so we must provide one transformation out of our 4. Clearly you can see it's reflection. So when we identify reflection, we must also identify the equation of our mirror line. Because we know the reflected image is always the same distance and perpendicular to the mirror line, this means our mirror line is always in the middle of our vertex of our object and the vertex of our reflected image. So if we divide the distance by 2, we can identify our mirror line. Looking at the question, you can see from this vertex to our corresponding reflected vertex, it's 6 squares. So therefore, the equation of the mirror line must be halfway between. We can verify with this vertex and this vertex. So therefore, our mirror line is here. To achieve our 2 marks, we simply identify Q is a reflection of P in the y-axis. We get 1 mark for reflection and 1 mark for identifying the equation of our mirror line. An alternative answer is Q is a reflection of P in the line x equals 0. This will also achieve 2 marks. Now let's look at another similar question where we're asked to describe fully the single transformation that maps shape A to shape B. This is also 2 marks. See if you can give it a go and press pause if you need. Just like before, let's identify our corresponding vertices and divide by 2. Here we have the vertex, which is 1, 2, 3, 4, 5, 6 squares away from our reflected vertex. So therefore, the mirror line must be 3 squares away from each vertex. Let's verify with another vertex. Here you can see from this vertex to our corresponding reflected vertex, it's 6 squares. So therefore, our mirror line lies 3 squares from each vertex. Here we have the equation of our mirror line as y equals minus 1. So, reflection in the line y equals minus 1 will achieve our 2 marks. Now let's have a look at a slightly harder question. The question wants us to describe fully the single transformation that maps triangle A to triangle B. It's worth 2 marks. See if you can give it a go and press pause if you need. We're going to use the same method and identify our corresponding vertices. Starting with triangle A, you can see we are 1 diagonal, 2 diagonals, 3 diagonals, 4 diagonals away from our corresponding reflected vertex. So therefore, the equation of the mirror line must sit 2 diagonals from each vertex. Let's try with another vertex. Here you can see we are 1, 2, 3, 4, 5 diagonals away from each corresponding vertex. So therefore, the mirror line must sit 2.5 diagonal squares away from each vertex. Identifying these points will help us so we can simply draw our mirror line and identify the equation of the mirror line is y equals x. So therefore, this is a reflection in the line y equals x. So, in summary, we've recapped on the 4 different types of transformations focusing on reflection. We've looked at drawing reflection by counting, ensuring the reflected image is always the same distance and perpendicular to the mirror line. We've also looked at using tracing paper, as well as looking at how an equation of a line can inform us what the reflected image coordinates would be. If you like this video, please give us a thumbs up. Leave your comments down below and subscribe to this channel, so you'll be the first to know when we release our next videos.